Okay, good afternoon everyone. Thanks for coming back after lunch. So this session is optimising VMware vSphere environments as well as vCloud and VDI environments using intelligent storage. Okay, a little about me. That's my ugly mug just there. So I'm a virtualization architect for IBM. Last year achieved my VCDX in data center virtualization in vSphere 4 and 5. I do a bit of blogging in my spare time, so some of the content I'm sharing today has actually been discussed on my blog. I also tweet, so feel free to give me some feedback on Twitter. There's a bit about my experience there. Basically been virtualization focused for about 6 years and a couple of certifications. I want to give a special thanks to Rob Waite, who is from NetApp. Rob actually was going to co-present today, but he's actually ill, so I'll be taking over. So Rob is a consulting SE at NetApp, and he also blogs and tweets and so forth. So make sure you follow Rob. Disclaimer, as always, the views expressed here are mine and Rob's opinion, not necessarily those of our employers. Okay, so today's agenda, we're going to look at current challenges in traditional vSphere environments, as well as challenges in virtual desktop and cloud. And we're going to go through some real-world scenarios and solutions for various environments. And we'll end with a Q&A. But feel free to raise your hand and I'll try and answer as we go. So starting off, vSphere challenges. Most of us have probably deployed vSphere and have been doing it for a number of years. And we've probably come across a lot of problems over the time, learning and so forth. I too have made problems had problems over the years, which is how we all learn. So the biggest challenge I find, business-wise, is time to market. So the business will come to me and say, Josh, we want to deploy this application and we want to do it tomorrow, or we want to do it yesterday in some cases. So how can we achieve that? So that's a real challenge in a lot of environments. Data growth is another one. So we have a lot of data growth. It seems to be exponential and hasn't let up since I've been in the industry at least. Then we have testing and development. So a lot of customers have applications that are mission critical and they need to do patching. So how can they do patching without interrupting their environment? And how can they do it so that they're actually testing real world scenarios and do that easily? RPOs and RTOs actually comes up under backup and recovery. If you're not familiar with RPO and RTO, it means recovery point objective, which is essentially how much data you can lose in the event of a disaster. And RTO is the time it takes to recover your application. So your RTO might be 4 hours or 1 hour or 24 hours, depending on your requirement. The other challenge we have is because vSphere is an abstraction layer, we do add a bit of complexity there. But I think that the added complexity is outweighed by the benefits we receive. So that's one challenge. Performance. A lot of people have P2V'd all their servers, got them virtualized, and then gone, oh crap, it doesn't work very well. So how do we ensure performance for mission critical, test dev, and so forth? Then backup and recovery. I'm sure all of us have seen an environment where we have agent level backups. We've P2V'd the servers, and then at 3 a.m. in the morning, the backup kicks off, and it runs really slow. And then it's a big disaster because your backups don't complete within your window. So that's a very common thing I see even today. And then the last is integration. So we've got vSphere, and then we might have storage or network. How do they integrate? And in a lot of cases, products don't integrate very well, and that can be a problem. So solutions to some of these problems. Time to market and testing and development. So we've got our production environment. How are we going to go and test that if we want to roll out a patch? Well, we could take a backup and restore it, which could take some time. We could try and clone the machine in vSphere, which again takes time and disk space. Or we can use a feature like FlexClone, and we can clone an individual VM or an entire data store or an entire environment with no overhead on the ESX host or the storage from a capacity perspective. So this is an example of how intelligent storage actually gives us better value or greater value in our vSphere environment. So the benefit of FlexClone is we're not writing the data again. So we take a clone, which is read-write, but we don't have to write the data out again. So there's almost zero overhead from a capacity perspective, which is really important. The next is Rapid Clone, and this is integrated in the Virtual Storage Console plugin, which is in vSphere. So the beauty of this, which I've got a demo of, is within vSphere, so any VCP or anyone experienced in administering vSphere can easily use this feature. So less complexity, you don't have to get your storage guy involved, much simpler. Data growth. Data deduplication. Not a very common feature in the industry unless you're a NetApp house. And I think it's so undervalued. I think people think dedupe's a bit of a gimmick, when in reality it's actually really important. So I'll show you a demo of that. Snapshot-based backups really help us address data growth because we're only taking one copy of data. Where in a lot of backup products, you take your initial backup to disk, and then you take it off somewhere else to tape or to another disk silo. So that's one more copy than you need. So there's other vendors like Actifio who streamline this as well. Very similar to how NetApp do it, which is what most of this is based on. So if you can have a backup to disk that's online ready to be used without costing you disk space, that really helps address data growth. So you don't have to have a whole bunch of SATA disks just sitting there for backups. The next one is user data. So a lot of shops have Windows file servers, and they replicate data for high availability using DFSR. And that's 2 copies of data when you don't need it. Excuse me. So if we put this onto a SIP share on a NetApp filer, or indeed on another vendor's array, it's much more efficient because those arrays are already very highly available. And the other advantage is you get rid of the pesky Windows servers. So we don't have to patch them or scan them and things like that. So it simplifies the environment and removes complexity. Performance. These 3 things here I find are very poorly understood in the industry, and the value of these is not properly understood. So VAI, so VMware's API for array integration, fantastic feature, and it allows you to offload storage functionality to the array. Now, that might not sound that impressive, but if I'm doing a storage vMotion and my host has to read the data and then write the data, that's traversing the storage network and taking up compute resources. So that's an overhead. So VAI gets rid of that. So the array moves it from point A to point B, and it does that intelligently. So therefore, less utilization on my host, I can consolidate at a higher ratio. And VASA. So VASA gives storage awareness to vSphere or vCloud. So when we place a VM on a data store, we know what that data store is. Whether it's tier 1, whether it's deduped or thin provisioned, we know exactly what it is. So that means we put the VM in the right spot, which means we get the performance we expect. So traditionally, you might have a SATA array, and you might not name the data stores efficiently. So you've put a tier 1 app on SATA, and you wonder why it doesn't work properly. So this feature here really helps us avoid those problems. The next is flash cache. Now this is a NetApp feature, but a lot of arrays have the same sort of thing. Now this is read cache. So I think we're all probably familiar at a high level with what read caching does. In this case, flash cache comes in the form of 256, 512 gig cards, as well as 1 and 2 terabyte cards. And because we use dedupe, it's deduplication aware. So if we have 10 terabytes of data deduped into 1 terabyte, we effectively have 10 times the cache. So that's why dedupe is actually, you'll hear NetApp people say it's a performance feature. And then you'll hear other vendors say it's sucking power out of your box. Well, in reality, dedupe has a small overhead when it does the dedupe pass, but once the data is deduped, it's actually a performance benefit. So small overhead, potentially quite a big gain. So that's why flash cache can be very good for read workloads. It doesn't do anything with write. So if you have VMware View, which we'll talk about later, that can be very handy for your replicas. Now flash pools. Flash pools is basically a bunch of SSD that is read-write cache. And that's for any of your aggregates that you want on a NetApp array. So the beauty here is when you have a workload that's write intensive, you can put it behind a flash pool, and then you'll get read and write cache benefits. So that's really important. So performance, some workloads require read, some require write, and some are a bit in between. So for read, use flash cache. For read-write, 50-50 sort of thing, use flash pools. And for heavy write or overwrite data, flash pools. And that will get you good performance. Backup and recovery. Don't use agent-based backups. It's 2013. We've had array-based backups for so long. It's a bit laughable that we still even have these in the industry, to be honest. So enabled value. There is quite a number, not just NetApp, so C and let's backups intelligently. So I've got a slide of this as well, showing you the screen. And then SnapVault, SnapMirror, and SnapManager. These are 3 products from NetApp, which again, there's other vendors that have similar, but in this case, I'll talk about NetApp. So SnapVault is where we take that initial backup, which is online, and we move it to either another array or on the same controller. So that's the only time we move data in the NetApp backup and restore process. It can be used for backups, but it's more traditionally used for DR and Site Recovery Manager. SnapManager is an agent that you put within a VM for things like SQL, Oracle, Lotus Notes, and so forth. And what that does is it doesn't move data like a traditional agent. It quiesces the application, and then once the application's consistent, it sends metadata to the array to take a snap. So it's not moving any data across your network. It's also not impacting your array. So that's really good because there's basically no overhead on vSphere when you use these tools. And that also helps performance. So you might need an RPO, for example, of an hour for your mission critical servers. If we use these tools, we can do that during the day with little or no impact to our application. If we use traditional agents, then it's a high impact. So being intelligent about backups actually helps with performance as well as data growth. Now, this is a video. No, that's a screenshot, sorry. Just bear with me a moment, guys. No, don't know why that's not playing. I'll just pull up Explorer. Okay, so basically this is the vSphere client, which you're all, I'm sure, familiar with. And what I'm going to take you through here is how we intelligently clone a virtual machine. So what we're seeing here, which I'll pause, is the VSC plugin. So we can see up here all of our data stores, we can see our capacity usage, and we can see our advanced features such as dedupe. So what we can see, for example, here is we've got 1 gig of space savings thanks to dedupe at the moment, and we've got 16% data store usage. You guys can probably see that better than me. So we're going to clone 20 desktops and just see how much space we actually use. And this works the same for servers and desktops. It just happened to be for desktops in this example. So there's no audio on this one. So we can see 84 gig free before we clone. And there's the space savings for dedupe at the moment. What we're doing here is we're right-clicking on a desktop, which is this one, desktop 1. And we're going to go down to NetApp. So this is where the VSC plugin ties into the vSphere client. And we're going to go through a rapid clone, which you can see up here. So I won't explain all of these various selections here, but you're basically just selecting the controller, selecting the data store, which cluster the cloned VMs are going to start up on, and then it's going to deploy, and then we'll watch that process. So here's where we're just saying how many clones we're going to do. Important to note here, I might pause that we can actually apply customizations to the VMs as we deploy them. So if your time to market objective is to get 20 servers out the door for test and dev, you could go 20 clones, as we've done here, give them a name, and then apply customization specification and power them on. So that way all those servers will be cloned, start up, sysprep, add to the domain, all that kind of stuff, and be ready to use very rapidly. So we'll resume that. So as I mentioned, it says desktop here, but it doesn't matter if it's a desktop or a server. And here we're just choosing an NFS data store, although this can work for block-based files as well, so Fibre Channel and iSCSI. It's also important that I point out here that this was done in a lab, so there's not a massive big controller behind this environment that's making this run fast. It's actually just the software. So you can see the task is kicked off, create a rapid clone of the virtual machines, and we can see we're straight away kicking off a flex clone of the virtual disk, which is almost done already. So this machine, just so you're all aware, is 10 gig. So it's not terribly big, but it's not small either. I haven't tried to trick you with anything. So there we go. Our clone of 10 gig is already done in a matter of maybe a minute. And then we've done a subsequent clone already. And it's been reconfigured. And as you can see, we've got all the desktops starting to appear now. So these are all full desktops or full 10 gig virtual machines that we're cloning just like this. And the reason it can do it this quick is because we're not writing the data over and over and over again, because we don't need to. If we were to write all these 20 desktops out, it'd be like 200 gig of data, which is all duplicate. So why bother writing it? So this is the intelligence I'm really trying to get across here. So as you can see, all of these tasks are just taking a couple of seconds. And in the time I've been talking, we've cloned, what, 10 already? And this would happen the same if the VM was 10 gig or 100 gig. It actually doesn't matter how big the machine is, because we're not writing data. We can also see over here, our capacity has virtually not increased at all in this whole process. So I think we're almost done here. The reason I chose 20 was I just wanted to show that it wasn't one or two machines. It was actually quite a large number of data, or a large amount of data. So throughout this whole process, there's actually no I/O happening on the host itself. So that's quite significant, because it means anything running in the production environment is not being impacted by this process. Okay, so there we see all of our 20 machines. I don't know exactly how long that took, but maybe 2 minutes for 20 machines. And we can see over here that our space hasn't increased. And just to prove that, we're going to do an update. So this just makes sure it goes away and talks to the array and says, is my data still up to date? So here we are, we've gone across, we've talked to the array, we're updating everything to make sure it's accurate. And then we go back here to NAS, happens to be NAS, but it could be SAN. And we can see here, we've used hardly any space at all, and now we've got 156 gig worth of dedupe savings. So it's 90% dedupe in what I've just done. Now what I'm going to show you here is what the virtual machines look like when they're rapidly cloned. Okay. So what you can see here is it's just a normal machine. You can see it's 10 gig, even though the video just finished. There's nothing different about the VM. It's all done at the array level. So this slide here, this is just it's not a video, this one. So I'm just showing here how easy it is to do a backup and recovery of a virtual machine with the VSC console. So all we do is we right click on a machine, the NetApp menu appears, backup and recovery, and we've got all of our options right there. So that's an example of integration that saves you time and money, because you don't have to go off to your storage team or your backup team to restore or back up a machine. You can do it yourself. So when the customer rings up and says, this Oracle server is now in production, I need it backed up 4 times a day, it's as simple as right-clicking, going to schedule, and changing it to happen every 8 hours. Very simple, or every 2 hours during production time. So we're on to the next section now, onto virtual desktops. So virtual desktops is quite interesting, I find, because customers go, all right, virtualize my servers, that went well, P2V'd all my thing, fantastic, job done. And then they take the same approach to virtual desktops. So speed of deployment, data growth, cost, performance, backup and recovery. Similar things to what we spoke about with vSphere. Now, in the VDI world, some of these things are very different. So if you just go and P2V everything, you might not get the result you're after. In fact, you almost certainly won't get the result you're after. So this maintenance task and speed of deployment, which I've actually shown you a demo of how quick we can deploy servers already, that's very critical to maintenance of desktop environments. We do a thing called recompose in the view world. And a recompose is when you update an image, take a snapshot, and then deploy it out to your virtual desktop fleet. Now, that's really I/O intensive because you're writing out all this data, even if you're using link clones. So that's one challenge, because that can actually bring your array to its knees, depending on how big it is. The next one's data growth. If we deploy 100, 1,000, 10,000 virtual desktops, and they're all the same, and they're all 10 gig, that's a hell of a lot of data. So data growth is a big issue. And that brings us to cost. If we're storing all that data, got to have lots of hard drives. Costs us a lot of money. Now, performance. We've touched on this with vSphere. Similar in the virtual desktop world, but we've got to be a lot more granular because there's a large number of users hitting the same storage. So this is very important. And backup and recovery. We don't typically back up our desktops, but we do need to back up our users' data. So it's important that their profiles are managed correctly and their user data is stored somewhere that we can back it up efficiently. So, again, we're going to use intelligent cloning at the storage layer to deploy our desktops. And we can do this with NetApp in one of 2 ways. Rapid Clone Utility, or RCU, is a tool that's integrated into vSphere Client, which allows you to clone desktops very similar to what I just showed you. The added feature set is that it will connect to a connection broker, register the desktop, and assign users. So it does that whole process of setting up a pool for you within this GUI. The only constraint with Rapid Clone is that it'll only do a manual pull, which for those of you familiar with View, not always ideal. There's certain use cases for manual pulls. Most people prefer, probably 80% of people, use linked clones. So Rapid Clone Utility can't do linked clones. However, we have a solution for that, which is using native NFS snapshot offload. Now this isn't a NetApp thing. EMC can do this as well. And basically what it does is you present NFS data stores, so a file-based storage system, and you can clone those desktops rapidly. And this is fully integrated with View. So I'm going to give you a demo of that. The next one is cost. So it's a fairly generic statement, but generally you don't save you save on OpEx, not CapEx. So your cost to set up a View environment might be the same as going physical desktops, but where you're going to save the money is CapEx. Now, if you do not use utilities such as these, you're not going to get your OpEx saving. So you're actually probably going to cost yourself money. And that's because it costs you money in storage, and more importantly, it takes your time. So as the View administrators, it takes a long time to perform these maintenance tasks if you don't have intelligent cloning, because you're moving a lot of data. Because you're moving a lot of data, it's high impact, therefore you have to do it on the weekend or at 3 in the morning. None of us want to be up at 3 in the morning. So this is how you get the job done during the day. The boss is happy, doesn't take as much time, and importantly, you get your CapEx savings. So data growth. deduplication. We've touched on this. If we intelligently clone, it's like deduplication in reverse. We don't write anything duplicate, therefore we don't have to run deduplication. So that helps with performance. Now, storage tiering. If you just have a big bucket of storage and you put all of your stuff into that one big bucket and it's a VMware View environment, it's probably not going to work very well. So storage tiering is very important. So we're going to talk about flash cache and flash pools again, but specifically on VMware View. Now, if it's high read, such as the linked clone replica, that's when you want your data store to be serviced behind flash cache, because your linked clone replica is where all your linked clones actually talk to. So if that image is 20 gig, for example, and that lives in flash cache, then it's got maximum performance at all times. So every time your users are connecting to that, it's going to be very fast. However, if you only use flash cache, then you're not getting any benefit for write cache. And write is very important. In fact, VMware View is about 65% write, traditionally. So flash pools, which are the SSD disks that we put in front of an aggregate, very good for writing or random overwrites. So for example, persistent disks and profiles and disposable disks. If you put those behind flash pools, it means you don't have contention between your high read and your high write activity. Because anytime we have contention is when our performance goes through the floor. And that's when your users ring up, and that's when you have to update your CV. Backup and recovery. So similar to the server world, in this case, we need to store user profiles and synapse and things like that. So why would we put that on a Windows file server? What is Windows giving us that we actually need? All we need is CIF shares or SMB, which is what Windows provides. If our array can do that, then we're not running another virtual machine or virtual machines and then replicating the data again. So we're removing complexity from the environment. The other benefit here is if your data is sitting on a CIF share on a NetApp array or an EMC array, then it's being read from the array to the user, as opposed to from the array to a server over the network and to a user. So we've removed that step, and that's why you get better performance. Backup and recovery. Same story as I just gave the example. If it's on a CIF share, we can back it up straight on the CIF share. We don't need to go to the Windows server, back it up, and back to the array again. So again, we're just removing these unnecessary steps. And because we remove those inefficiencies, we get performance. There's another video which won't work. So let me go back here. Okay, so this video is of VCAI. And this is how we use the intelligent snapshotting, which is the NFS snapshot offload function, with VMware View. So for those of you who haven't set up VMware View, this is the View administrator, and this is how you create a pool. And a pool of desktops is what you need to do. So we'll kick that off. So we're going to run through this very quickly, because the point of it is to show how quick the deployments are and how easy it is. So all of what we're doing here is creating a View Composer linked clone pool, and that's our vCenter. We're going to give it a name and a whole bunch of other details. And when we get into the point where we configure this native NFS offload, I'll pause it and I'll show you how simple it is to set up. So the only real prerequisite to this is that your array supports this feature, and you'll more than likely have to install a plugin on your ESX hosts to support this. You definitely do with NetApp and EMC, so I'd be surprised if anyone else can do it without a plugin. So here we can have persistent or disposable disks. In this example, it doesn't matter either way. Here we're just selecting our snapshot, which will be the basis for our linked clones. So none of this is about the storage layer just as yet. And it's very wizard driven, so it's very easy. And I think the point of this demo, or one of the points, is to show you the integration between the storage and vSphere and virtual desktops, and how easy it is. Because if we had to go to another console to do this, it's just another step and another layer of complexity, which takes time. So here we're just saying what resource pool the virtual desktops will go in, and what data store. Now the only prerequisite is, apart from the agent, is if you want the fast clone or the NFS snapshot offload to happen as fast as possible, you need to have them on the replica on the same data store, okay? Which is fine because we've got NFS data stores which can auto grow and all these wonderful things, so it's actually not really a big deal. If you were to select one of those other data stores where the replica was not housed, it would do a clone operation, which is a traditional clone, so you'd write some data and then it will intelligently clone the rest. So even if you choose incorrectly, it's still very efficient. So that's all you need to do to enable this feature, is tick that tick box. You'll notice it says Tech Preview. Technically, VMware don't have to provide you support for it in the current version. So vSphere 5.0 and View 5.1 or later. That will be gone in the next version, or so I'm told. Basically, it works very well. I've used it extensively, but technically, just so you're aware, it's Tech Preview. So that's all you need to do. Tick that box, and as you can see, it's in the Add Pool wizard. It's there by default. You don't have to do anything special to add it. If you haven't installed the plugin, it'll just be grayed out. So if you go through to set up your pool and it doesn't work, just go back and check if you've installed the plugin. And now we'll hit finish, and we'll see how quick. We're only deploying 5 desktops in this case, but it's the same concept as what we saw earlier. So here's our VSC plugin again. So here we can see the tasks started. So we're discovering the storage just to make sure everything's the same. And you'll find generally with View there's about a 20-second delay from when you hit something in the View Administrator to when it actually takes effect. That's actually by design. So here we can see currently what space savings we have, which I can hardly read that. 2.5 gig, I think that says. So here we go, we're starting our clone. And as you can see, very similar to the other example I showed earlier, they happen very quickly. And that's because it's all offloaded to the array. So it's actually the same technology that we deployed using servers. So really what I'm demonstrating here is the integration and how simple it is to use these features. And there you can see the VSC plugin. Simply appears just like Site Recovery Manager or any of the other tools. And what we'll see at the end of this is how much space we've used, which again, no surprise, is going to be almost none. Okay, so we're back. You can see our data store usage hasn't changed, but now we've got a whole lot of space savings from dedupe. And as I mentioned earlier, it's not actually dedupe. So it's dedupe in reverse. Okay, so we're running a bit short on time, guys. I'll cut that a little bit short, but you've already seen how it works. Okay, cloud computing. Who here has deployed vCloud Director in a production environment? Nathan has, that's good. So no one else? No? Okay. So we can avoid some of the mistakes that you were going to make by paying attention here. So time to market, very similar to vSphere. People want vCloud because they want to deploy things quickly. Data growth, costs, similar stuff to vSphere. Performance, backup and recovery, but here, importantly, vCloud hosted workloads. So you can put an agent in any VM you like, whether it's hosted by vCloud or not, and you can back. But how do you ascend to vCloud? And are you aware of the various layers within vCloud to be able to restore it correctly? And the answer is 90% of products are not. That's even today. So time to market. We want to deploy some VMs in vCloud. How do we do it? We used fast provisioning. I've actually written fast clones here, but fast provisioning using that feature I just demoed, which was native NFS snapshot offload. So we're using linked clones, but for servers, so we can deploy them really fast. Again, performance benefit, because those linked clones sit in flash cache. So we deploy them faster, and then they run faster because they're in cache. Data growth, again, dedupe. A lot of these things overlap, which is why it's quite important to go over them. The next one, let's say you've got your cloud environment, and people are deploying apps left, right, and center because it's really cool, really easy, and your LUNs start to fill up, right? You're running out of space. So if you use NFS and these native snapshot offload, you can auto-grow your NFS mounts, okay? So if you get to that threshold, the NFS mount will just grow, and then you won't have that situation where all your VMs pause and go offline because you've got no space. So very good if you're a public cloud provider, for example. So fast provisioning, this feature I talked about here, is vCloud 1.5 or later. And previously, before this feature was there, it was a full clone operation, which took compute and storage resources to complete. So VASA, we've talked about these before, but I'll talk about them again. vCloud is VASA aware. So when you place a machine in vCloud, you can pass through this storage awareness from VASA so that you put your VM in the right data store. Because we've got that extra layer of abstraction when we use vCloud Director, it's really important to make sure we don't just put all of our VMs just in one big storage DRS pool. Okay? Otherwise, we might not get the performance we expect from flash cache and flash pools. Lastly, this is very important. So backup and recovery is always neglected in my experience. So we need to be able to back up the vCloud environment. Okay? So we have an organizational virtual data center, for example, and that could be one customer if you're in a multi-tenant environment. So how do we back that up? Do we put an agent in all the VMs, back all the VMs up separately, and then try and work out which customer's which? Well, no, that'd be a security violation. It'd be very time-consuming. Not a good idea. So Snap Creator is a NetApp feature, and it's actually complemented by Snap Protect, which is an OEM from Commvault. And we can actually back up and restore things hosted in vCloud. So we can actually give permission to a customer to log into Snap Creator and back up and restore their own VMs. Now, how cool is that? They don't have to call your help desk to get their VM back. So that's really important. Most importantly is it's vCloud aware. Thanks, Nathan. So if it wasn't vCloud aware, then you would have to manually import that VM back, okay, which takes time, complexity, and it might not work correctly. For backup and recovery of your management cluster for vCloud, which you always should have a management cluster, you can do that with VSC, which I demonstrated with that screenshot earlier. So use VSC to back up your vCenter, your vCloud Director cells, your SQL or Oracle server, and so forth. And then all of it, regardless of how you use it, whether it's Snap Creator, Snap Protect, or VSC, you snap vault it or mirror it offsite. Okay, and all that is done intelligently without impacting your cluster. Now here's just a screenshot of, in vCloud, how we enable fast provisioning. It's actually enabled by default, but I just wanted to show you the tick box. So that's just going to be grayed out if you don't have VAI enabled or the plugin required. So that is it. So we can open up to questions if we have a moment, Nathan. Yep. Fire away. Yep. Yes. Yep. You do. So the question for those who didn't hear was, when you flex clone a machine, if it has multiple vDisks across multiple data stores, can you do that? Is that fine? So the answer is yes. So it can. So basically, when you flex clone the machine, Obviously, under Edit Settings, you can see where all the vDisks are. So the FlexClone process takes note of that and clones those. So it doesn't move data. So wherever it is, it remains there as a read-write copy. So all the deltas are written to the same locations. Does that answer the question? Yeah. And then, yes. Okay, so the question was, with the VSC plugin, which we showed earlier with the backup and recovery, how granular can we get with the permissions? So can we give one user just restore or one user full rights? The answer is yes, there's some permissions. It's not as granular as vSphere, which has got hundreds of permissions, but yes, you can do that to a point. Yeah, that's correct. Although I think if you were going to do that, you would probably want to go vCloud and give them access via Snap Creator. That would probably be a safer way to do it if it's multi-tenant or multi-departmental. Go for it. So it previously was called Snap Manager for Virtual Infrastructure. So Snap Manager for Oracle you would set up separately. So you install that into the guest, and then Rob Waite would have been better to answer this, but basically you set up Snap Manager in the VM, which quiesces the application and takes backups of the app at a certain schedule, and VSC, or SMBI as it used to be called, does the VM itself. So it's sort of two components. Yep. That's correct. So you'd want to be, that's exactly right. So you'd use VSC to take a backup of the VM as a whole, and then you'd use Snap Manager to take that on whatever your interval was for your recovery point objective. Yep. I think we'll have to wrap up, guys. I think I went over. I'll hand back over to Nathan. Thank you.
Thanks very much, Josh.